Hey, how's it going, guys? This is Eugene from Untitled Designs. Today, I'm going to try doing something a little bit different. Normally, on the projects that I'd worked with you guys previously, is that I had create a finished design, done something, and then created a video after it about what I had done or the learning process behind it. But this time, I want to try doing something a little bit different. I wanted to actually bring you guys along the process of actually creating the final product. So I'm doing a live stream, so that way I'm actually going to be making all of the CAD for the first time right now and kind of explain to you what the thought process is behind it. And then after that, I'll be making a, shortened, edited version of everything. So if you just want to get the gist of how it was made, then you could get that as well. So you can see on my screen what the concept as to what I'm trying to make is. My brother had shown me this, which is basically an LED winch. So it's used for like music concerts and that type of thing. All it really is a motor with a little wire that is pulling that wire up or down, and then there's a different type of LED that can be attached to it. So this one can extend up to 60 feet, and they have like an array of 1,000 of them or 2,000 of them they have at concerts. But obviously this is going to be too expensive for any, lay person to be purchasing. So I wanted to do something that was along the concept of that, but maybe a little bit more cost effective. So my concept for doing that was going to be buying just LED strips. So this is the WS2812B. Individually addressable LED lights, which just basically means it's an RGB LED that I can control every single light in here individually, turn it on or off or set the color of it as well as the brightness. So I want to take that. I want to take something along a tape measure and then attach the LED strip to this. So that way the LED strip is going to be running all the way along this. Make it so it could be wound back inside of a small form factor, just like a tape measure, and then have a motor that controls it so it can go up and down. And pretty much all that information is outlined inside of here. So the main innovation is just making a small, compact form factor, but as well as being able to make something that can go up vertically if all the LED lights were on here. I could also make it so it could go horizontally, so there could be the box is mounted to a wall, and because a tape measure's, able to hold its, it's able to stay horizontal as you pull it out, then that means you could have it like mounted on the wall going out horizontally into space, which might actually be pretty interesting. And the complicated part at the end of it is going to be figuring out how I can make a modular system that could be integrated together. So making a single unit probably isn't going to be all that complicated. It's really just a LED strip, like a tape measure type of mechanism, and a motor that pulls it up and down, and then you program it so you set the lights and whatever it does. But making it so that way it could be as shown in the image below, that you could just basically connect the two, a whole array of them together through magnets or whatever it may be. So they all join together and then write a program that controls all of them. That's where the complicated part comes in play, and that's also where I'd be going into a little bit about Fusion 360 now has some PCB design, so designing your own circuit boards. That I'll be going to that a little bit if it gets to that point, and if the product ends up being viable to be able to make that. So the first milestone that I'm going to be going after is creating the CAD design. So the first thing I need to do is basically define what are the starting points that I'm working with. So what materials I'm working with, what's going to be required inside there, what's the first minimum viable product that I'll be able to make just to prove that the first concept works, and then move on to the next stage, move on to the next stage. So the first thing I need to do is I need to figure out how to take this LED strip that I have here and then attach it to this tape measure and make it so it could be wound down into a small form factor. So I'm going to have to take this tape measure apart, take those LEDs and adhere it onto here, and then just see what kind of housing I would need to have for the tape measure for it to actually be able to fit the full length of LED strip. And what I'm planning on going for is going to be about 4 feet. That in distance will be the absolute max that it can go. So I don't know if I'll be able to get this in camera. 4 feet is, let's see. Yeah, I can't quite get it. This is 4 feet long. So I would take the LED strip, and the LED strip is going to be going and sitting on top, and that would be the full length it'd be able to come out. So if it's going up vertically, it'd actually be pretty high that it's going up. So that's going to be the max length I'm going to be working with. And then what I also need to decide upon is what side of the tape measure I'd actually want to be having the LED strips on, because either I could have it so that way the LEDs are on the top of the curve, which might make it a little bit more sturdy, not sure, or I could have it underneath the tape measure on the underside, which actually I think would be more interesting, because then that would mean that if this mechanism of it coming out works properly, and let me just switch my camera over to just the full camera. So if this mechanism works properly, I can make it so that way the LEDs could be on the underside, and then this could actually be basically like coming out from the wall, and then just an array of LEDs come out and flash on and off, and you could have a whole row of them running along, the wall, and I think that could be something that visually be interesting. So let's jump into Fusion 360 and kind of outline what the basics that we need to start with to be able to make this CAD model, and that is going to be basically making the design that has the tape measure with the LED strip adhered to it, and making that in CAD, and see how tight I could possibly get it wound in order to see how tight of a form factor I can get it to be if I'm trying to get 4 feet of measuring tape rolled up inside of there. So if I go into Fusion, this was just a dummy model that I had made to, let's see, music had stopped. Dummy model I made just to kind of show what the initial concept was. Oh, and I didn't switch the camera. Okay, there we go. Now you can see what I'm seeing. All right, so this was my initial dummy model. I'm gonna create a new design. So there's 3 things we're gonna be working with. First are gonna be the tape measure. So I need to get the dimensions of this actual tape measure that we're gonna be using. I need to get the dimensions of the LED strip that we're going to be using, and then once I have those numbers and everything figured out, then I'm going to have to create the CAD of the housing that this is all going to fit inside of. And just to kind of show you a demo of what the LED lights look like when they're turned on, if I move my camera down, I also forgot to mention, so this is being controlled by an Arduino. So I had already soldered some wires on here. I got a little bit ahead of myself, but I'll just give you a little demo as to what it can do. So I'm plugging the Arduino into my computer. And then next, that should be enough, actually. So this was just some pre-programmed code. These LED strips are fairly common. So I'm using the fast LED demo code. So if I go over to here in the Arduino IDE, and I know I'm kind of jumping into this, that I haven't gone over coding or anything with electronics on my channel before, but I will get more into depth once we actually need to get to this. But this is just showing you could just buy this LED strip, attach an Arduino to it, plug it into your computer and run some example code, and it already does some interesting things. First thing that I'm going to do is I'm going to open back up my CAD model. open back up my CAD model, and I'm going to start by creating the generic model for the tape measure. Well, I guess I can't start with creating a tape measure, so the first thing I need to do is I need to actually model the spiral and get the spiral to be the length that we need, and then I'll create the profile of the tape measure from there, right? The tape measure plus the LED strip. So first thing we're going to do is I'm going to go to, I'm going to save the file, and I'll just call it LED wall art. And I'm going to right click on where it says LED wall art and create a new component. The component is just a container in which all your history is going to be stored. So I'll call this demo spiral. And this spiral that we're going to be working with is just going to be a baseline, so we know the length that it's going to have to be, and then we'll create the actual tape measure and LED strip at a later point. So I'm going to go to create and go to coil, and I will create this on the front plane. I'm going to click in the middle. I don't know what the actual diameter that it's going to end up being in the end, so we'll just say this is all in American units. Let's get a caliper. We'll say it's going to be roughly 100 millimeters in diameter once it's wound up. So we'll put this to 100. And I already had this set to spiral because I was playing around with it earlier. Normally it's on revolution and height and circular, so normally you'd start with something like this. So what you would need to do is go to type. We're going to go to spiral. And because I'm just going to be using this spiral as a basically path that the actual CAD is going to be going off of at a later point, I'm just going to set it so the section is triangular internal, because all I really care about is this line that's on the inside that wraps around here, and that's what I'm going to use to be able to make the tape measure design. I'm going to change the rotation just so that way it's going up, which is how I'd want it in my CAD. All right. Next thing is the section size. So the section size is really going to be dependent on how thick this tape measure is. So I'm going to have to double check to see how it actually calculates the section size for a triangle. But if I take my calipers and I just measure basically the thickness of the tape measure while it's bent, and it has that arc on it, it says 5 millimeters. So I'm going to set the section size to 5 millimeters. Okay. Next thing, what we're going to do is we're going to adjust the pitch, which is going to tighten the whole thing up. So we'll try doing it at 10. Okay. And we'll just do okay. So last thing we need to do, and all we're trying to do is get the correct length of spiral to start out with. So if I go to inspect, go to measure, if I click on this line, it tells you the full length of it, and that says it's 1187 millimeters. So if I'm going 1187 millimeters to inches, so 46 inches, and I was going for 4 feet, which is 48. Wow, I got pretty lucky. Or I guess I'm just good at estimating. Okay, so I think this should actually be just about the perfect length that we would need, because we're going to have the amount that's actually wound up internally inside of the case, and then, so let me just go back to the CAD, or go back to my example. So we're going to have the amount that's actually wound up internally inside of the housing, and then we need to have a little bit that extends beyond it. And that's just so that way, when we have a motor in there, we're going to be able to push it back up. So I'm going to extrude this up a little bit. And once again, this is just for like a rough demo, or this is just a profile of the actual sketch that we're going to be using. So that looks good. So this works as is. This is the exact length that we need it. So from here, I could go and start creating the profile and make the actual make the profile of the tape measure plus the LED strip on there. But from how I have it designed right now, it isn't the most compact on the inside. I could still make it a little bit more compact and dense in the middle. So I'm going to go about and making that change. So I'm going to double click on the demo spiral and the design history down here at the bottom. And let's see what I can do. If I adjust the, no, I don't want to adjust the revolutions. Okay, so the diameter that's specified is the interior diameter, the smallest that it's ever going to be on the inside. What we're going to do is we'll cut that in half. That 50 millimeters in diameter is probably, you know, we'll go even smaller than that. We'll go to 30. So 30 millimeters in diameter will be the smallest that we're working with. And that's going to adjust the whole length of everything. So I'll adjust the revolutions to 5 and then click OK. And then let's just remeasure this. So I'm just hitting I on the keyboard and clicking on this internal loop. This is 1179, which is almost exactly what it was before. Let me just double check to make sure everything in the stream is going fine. Okay. So that looks good. And just so everybody has a reference, I should post a link to this Figma design just so that everyone has access to it. So if somebody joins at a later point, they're able to see. So copy link. Does that work? There we go. All right, now there's something in the chat. Okay. Okay, so now we need to go about creating the profile of the tape measure, and then we need to create the profile of the LED strip that's going to be going inside there as well. So I am going to create a new component. So I'm going to activate the main body and then right click and go to new component. And I will call this, I'll just call it steel tape. And now what we need to do is we need to create a sketch on the starting profile of here, of the spiral that we created. And I'm going to project just that very tip point, because that's what we care about, that internal diameter that's in there, because that's the smallest we're ever going to want it wound up. So now that I have that created, I need to create what is the actual profile of the tape measure itself. So I need to get the width of the tape measure and then the arc of the curve that's in here. So if I measure this, so I'm measuring, this is 21 millimeters wide, and I had measured this before. This is 5 millimeters in height. So 21 by 5. So what I'm going to do is I'm going to first create a vertical line and set that as a midpoint and make a construction line. And now I'm going to make a 3-point arc and select the bottom of the line, the top of the line, and then just some point in the middle to be able to make the profile of the tape measure. So we had said it was 21 millimeters in height, and then the distance from here to the tangent of the curve is 5 millimeters. So I'm right clicking and I'm going to pick circle / arctangent, click on that, click on there, and we're going for 5 millimeters. And that fully constrains that whole arc that we're making. Last thing we need to do is define what the thickness of this tape measure is. So let's just get that measurement. I'm measuring 0.1 millimeters, so it's very thin. So I'm going to do an offset, 0.1, and then I'm just going to connect those two. The side profile may not be perfect, but for all intents and purposes, it should be good enough. Okay, so that's the sketch for the tape measure, but the sketch for the LED strip is going to be following the exact same process, so I could combine the two together and put the LED strip in this same sketch as well. So I think what I'm actually going to do is this LED strip has this, like, I don't know, plastic casing around it that is supposed to make it so it's IP67 waterproof and that kind of thing, but I don't particularly care about that for what I'm trying to do. So what I'm going to do is I'm actually going to open it up and cut it, just because I think it's just getting in my way as of right now. And it's adding a whole bunch of extra weight to this design. So I'm going to take this. On this end of it, there's some extra wires. And you can see I'm going to just be cutting off that whole like whitish housing around it. And then I'll probably end up putting some kind of casing around it so it's somewhat waterproof, and also so that way you don't see the LEDs directly as much, because I think I would want the light to be diffused and not just a full solid color, or you to be able to see all the individual lights. I think I kind of want it so that way you can't really see all of those lights in there. It's all kind of faded into each other. So right now I'm just going about cutting this open, and I'm going to cut a length that's I'll do 5 feet, just because I was going for 4 feet was the total length that I ever wanted to be coming out at any point. But just because there's 4 feet of LED that I'm going to have in there, I'm going to probably want this to be a little bit longer than that. So I'm going to need to cut this a little bit longer. See if there's a quick and easy way to get this to keep going. And there isn't. So I guess we'll go with a low and slow way. And the reason that this particular LED strip was picked was because it's widely available on Amazon, and it has the code to be able to program it or have examples for it. So I didn't have to do really anything to get this thing up and running. I just needed to buy it. Oh, that's a lot better. Buy it, connect an Arduino to it, and then it was pretty much good. All right, I broke this here. Let's see, I'll take that section off. Yeah, it's gonna be a lot thinner. So I am gonna have to buy another LED strip, because I actually really wanted one with an adhesive on the back, and this does not have that. All right, well, I'm not gonna take this whole thing off right now. This is too much of a pain, but what this does let me do is get an accurate measurement as to the size of the actual tape that we're gonna be working with. So if I get my calipers, the tape is 10 millimeters wide. The max, well, we'll just get the width of the flex tape behind it, 0.25 millimeters thick. And then the LEDs are 50/50 LEDs, so they're 5 millimeters by 5 millimeters. And they are 30 millimeters. Is it 30 millimeters? It's a little bit more than that. I'll say 32.5 millimeters apart from each other. So let's put that into CAD. Let's get my camera back up. the tape that's on the back of it is actually going to be curving with the back of the tape measure a little bit. So it's not going to be quite flat. And yeah, it could curve just right along with that. So what I'm going to do is I'm going to make another 3-point arc. So we'll go hit S, and S is a very convenient shortcut. It just automatically lets you type in what you want to do. Actually, I want to do a center point arc. So center point, so I'm going to click center, rough shape that I want. All right, and we're going to do the same thing. We're going to make a line, make this horizontal / vertical. Now, yeah, okay. So I would say you normally want to model everything as exactly as it is, as it's going to be in real life. But I think for this, I'm going to just keep it a little bit simpler, just because I'd have to get the length of the arc. You know what? It's not a big deal. Let's do it right. So we'll do center point arc, make these two concentric, I believe is what I want to do. No, equal. Nope, that's not what I want. What I can do is I can just make it an offset of the line that we already have. So I'm going to undo chain selection. It was minus 0.25 millimeters. And then the width of it was 10 millimeters. So I could do some math to figure it out, but I'm going to just estimate or guesstimate to be able to get it to be where it needs to be. So I'm going to delete the edges on the side here. So this is already the distance that we want it to be. I deleted one of the lines I didn't want to get rid of. Delete that. Delete that. So that's the radius we want. And now I need to measure this arc and get it to be 10 millimeters. So I'll do measure, click on it. Length is 5 millimeters right now, so I need to just about double it. Why are those two not coincident? Music stopped again. Let's keep it going. Let's see, what is it at right now? And you know what? I'll set an actual length of it just so. Let's set that. That's going to make it too long, but we'll see. All right, we're at 10.25, so we'll do 9.75. Does that end up with what we want? Close enough, 9.984. And just double checking that measurement again to make sure I have it right. In the thickness of it. Yep, 0.25. Okay, so I got the arc of that tape correct now. And I didn't need to make a line behind it because it's going to be right up against that tape measure. I'm going to make these two lines construction lines, actually, just so that way it's a little bit more clear as to what they're being used for. And I am going to, let's see, that's going to break everything. I'm just going to make a line going over it, just like that, just so the ends aren't construction lines and we can have the closed shape that we're looking for. Okay, so now we have the finished model of the tape measure, which is this section right here, plus the flexible tape that is the backing on this LED strip. We're not going to make the LEDs just yet because we need to make a pattern for those separately. So I'll do finish sketch. And now what we're going to do is we're going to use the sweep command. And that lets us take a profile. So we're going to start with doing the tape measure first because that's what we have selected as our component. So I'm going to select the profile of that arc that we're working with. And then the path is going to be this line right here. And there we go. Now, we'll see. So one thing to think about is that a tape measure, when it's actually wound up, I don't think it stays in this shape. It flattens out once it's rolled up inside there. So that's going to maybe throw my dimensions off a little bit, but I think it should be fine. So we got that, and then path I'm going to select so it does that little section on top as well, and do OK. All right, and now I'm going to hide the object of the demo spiral. So this is what the tape measure is going to end up looking like in the end, and just to make it a little bit more clear as to what it is, I'm going to set it so that the appearance, sure, capped on is good enough. It's yellow, you know what it is. It's a tape measure. Okay, so we're going to create the next component, which is the LED strip. So I'll go to New Component. I'm going to call this LED strip. And then I'm going to make another sweep that's using the exact same profile. So I actually need to turn the demo spiral back on. I click the profile of the flex tape on the LED strip, and now I'm going to go to Path and click on the top edge of that spiral that we made earlier. Repeats the same thing, and I have to add to the path for that little straight end that we have in here as well. Okay, so now we have the tape measure plus the flex tape that's going to be on there. And we are going to make that black just to match what it actually looks like. So I'll just throw in some gray, edit it, and I will adjust the color. And it is being shown off screen, so you can't see it, but I changed the color. Okay, next thing we need to do is we need to create the LED chips that are actually on there. So I measured that it's a 50 by 50 square. I also need to add what the height of it is, and I'm going to measure the height with it plus the flex tape. So I'm measuring 1.85 millimeters. So if I subtract 0.25 millimeters from there, it is 1.5. Yeah, 1.6. No, 1.6. Sorry, math. So it's going to be 1.6 millimeters in height for those little squares. So what we need to do now is make one of those and then pattern it onto there so it goes along that whole LED strip. And we measured that they're 32.25 millimeters apart. So to do that, we first need to pick a starting point for it. So I'll go to Create Sketch. And I'm going to make a sketch on the front plane and slice it in half. So I'm going to make the first LED chip right around over here. So if I just make a rectangle, and it is 1.6 millimeters in height. Ooh, where'd it go? And it is 50 millimeters in width. No, not 55. That seems way off. Okay. And now I'm going to make a projection of the top here and just say it is going to be, I gotta make these two parallel first. I think they should be parallel already. All right, we'll do, I'm just doing it from the point just so it's a little bit easier. So now it's 5 millimeters above that edge, and we're going to want it to be coincident with this point right here. So I'll click on the line on the back here and then click on that purple dot and make it coincident. And then that is going to be the rough placement of our LED. So I'll do Finish Sketch. And now what we need to do Really, I should make a... it might be beneficial to make a new component that is each of those LED chips. And the reason for that is it makes it easier when setting the colors for things, or I can get the CAD model of the actual LED chip that's going inside there, but I don't think that really adds much value to what we're doing. It's not going to make it really any more or less accurate. It's just a little square, so we're not going to bother with that. So I'm going to right-click on LED strip and go to New Component, and I'll just call this LED. And now I'm going to go to that same sketch we just made, and I'm going to do an extrude, make it so the direction is symmetric, and the measurement we're going to want to set to whole length, and the whole length is going to be set to 5 millimeters. Ooh, not 56, 5. Okay, so you can see we got that LED chip in there. It looks like I actually made it so it's cutting through that tape, which is not what we want. Yeah, so I did it to the back instead of to the front, so we're going to need to go back into that sketch and make an adjustment, because right now it's not extruding out as much as it's supposed to be. So I'm going to go back and activate LED strip, go to the sketch, slice. And what's the reason that... okay, so the reason that it's cutting into there is because the arc that we're working with in the back is curved. So we're going to need to just move the LED chip forwards a little bit. So instead of it being coincident with this point here, I'll set it so it's a little bit farther forward. So we'll go by 0.2. Let's see what that looks like. Finish sketch. Yeah, that looks good. In reality, well, you know what we can do, just so it's a little bit more accurate, is that I can make the profile for the flex tape match it exactly. But I think that should be fine. I don't think we need to go too crazy on everything. So there's a single LED chip. Now what we're gonna have to do is we're gonna have to pattern it all the way around this spiral. So I'm gonna hit S and then go to pattern. And I'm gonna go to pattern on path. So pattern type, I'm gonna go to component and I'm gonna select the LED chip. And the path we're gonna use is the demo spiral once again. Let's see, it's saying it's an invalid input. So we're going to want it to be set to spacing, and the spacing is going to be 32.25 millimeters. It's doing something funky right now, so orientation is path direction. And what else do I not have right? Let's just scale this down a little bit just to see what we're working with. So go to path, select that arc. Okay, that's correct. If I select this whole thing, now if I set it to do 10. Alright, well that's going along the curve. Not quite exactly as we want it to go though. Alright, so if I set this back to 32.25, let's see what this looks like. Okay, so the problem that we're having right now is that this isn't actually up perfectly vertically. So each of these LED chips is at a slightly wrong angle. So I'm going to go back into the original sketch that I made and make sure that it's perfectly vertical. So just to have this all set correct, so I have it set to 32.25, and I can just keep on increasing the quantity until it gets to go all the way to the middle. Looks like it's getting worse as it gets? Yeah, it's getting a lot worse. All right, so 39 LEDs is how many is going to fit inside there. And it seems like I'm going to have to play with how it's going about making these, because I don't know if this is going to be correct. So let's go back into this initial sketch, and if I slice, so instead of having it so it's just 0.2 millimeters away, if I make a line, or let's see, if I project, yeah, if I project this line right here, we could see if I do a dimension between these two, oh no, that's straight. Why is it giving me problems? At what point does it not like the arc then? Alright, so let's do 0.25, so I have it a little bit farther away. Still not turning correctly. So I think it's because it's the starting point is off. I think that's what it is. So if I go back into this initial sketch, and we're going to try moving it up to the exact same height as where the end of this is. So if I set that to be a midpoint, I can't do that. So I'm going to have to make a line, make it a construction line, and set it to be horizontal/vertical, and then I'll set that to be in the midpoint. So that's in the middle there. Let's see if that fixes it. There we go. All right, yeah. So the reason that I was running into the problem was because the path had started up over here, and then the actual first LED chip was a lot lower than that. So basically it was just guessing where the angle at which I had to rotate, it was just wrong. So now I have this LED chip that's hanging out here that we don't want at all. So I'm gonna have to go back to the pattern, and I should be able to disable a specific one. And I can't because it's the very first one that I created. So I'm gonna have to just go over here, it says LED 1, we'll have that hidden. I actually kind of like the way this looks with having this clear housing over it that's from that demo spiral that we have. So I think I'm going to model in right now just something that gives a similar look to it, but is actually intentional. So we'll hide that demo spiral. I'll turn off that LED strip. And now we're going to need to create a new component. And I'll just call it LED cover. And then this, once again, just to save on the number of steps that we're working with, or the number of steps that are in this design history down here at the bottom, I'm going to go back into the original sketch I made right over here. That was the profile for the tape measure and the flex tape for the LED strip. And I'm going to make the profile in here, and that makes it so there's just less clutter as you're going through and you're making these things. So that way there's one sketch that I could see, this is the profile for the tape measure, this is the profile for the LED strip, and this is the profile for the part that covers over it. And that just helps keep things simple, so that way there's only one reference you have to go back to, instead of having like 4 or 5 different sketches, or I guess maybe just three sketches that you're going back and forth between on these things to be able to understand how things are referenced. So it makes it simpler, but you also have to try to make sure that eventually it gets too complicated on having too many different things going in here at once. So you don't want to go too crazy with it. And the values that I'm putting into here are kind of arbitrary. It's just whatever I think is going to look good. So that profile is going to be what is going to be covering that whole LED strip. So I'm going to activate the LED cover, go hit S and go sweep. And we are going to sweep along that whole profile using that demo spiral. Does that whole thing. It's covering the whole thing right now because we don't have the material set as something that's clear, but we'll be able to quickly change that once we have this new body made. Okay, so that's good. I'll turn off the demo spiral, turn off this sketch. I can turn off the sketch by just clicking on it, and then you could see which component that it's under, and then I could just click the little eyeball for the sketch and turn that right off. Let's change the appearance of this cover that's going over here. So I'm going to hit A, and that opens up the appearance menu. Go to transparent, and we'll just set it to be acrylic. I don't think it's not going to be made out of acrylic in the end, but just giving it a starting point. Okay, so it looks like this is a fairly decent start for the LED strip, but one thing that you will notice is that this isn't obviously nearly tight enough that it's supposed to be. When this thing is wound together, all of those layers are going to be pressed up against each other. So I'm going to have to go back into the initial demo spiral and tighten it up more and more until I basically get it so that way this cover here is going to be in contact with this surface here. So I'm going to go back into this first spiral that I made, and I'm going to reduce the pitch. Let's change it to say 8. I'll try 7. And then click OK. And I don't think everything should break from doing this, but we'll find out shortly. Nope, everything didn't break, which is good. So we got a little bit of funkiness right over here. And okay, yeah, the tape measure is completely off right now. So that means this initial sketch. No, that's fine because that's related to that one. So what is off? So that's fine. That only goes to there. And then let's go to this one. So if I just deselect the path and reselect it, is that going to solve all my problems? No. Let's do the profile as well. So we'll go to Sketch, go here. Now why does it spin beyond where it said it should go? So if I do 0, I do 1 here. Okay, that was weird. And the music stopped again. So for whatever reason, when I adjusted the diameter of that spiral, it still thought that it had the previous path that it was going off of before. So I just need to reset with the path that it's working with, and then it seemed to fix the problem. Or maybe I'm still wrong. Okay, well, it's wrong right now, but we are going to leave it as is. It's weird because it's just on this sketch that it's having the problem. We're going to leave it as is because I still need to make the whole sketch tighter because this still isn't quite touching that. So let's make this adjustment. Let's go back into here. We'll set the pitch to be 6. See what that's like. Or, well, if I did this correctly and the section size of 5 actually does what I think it's supposed to do. If I change this to 5, so that's just touching that, and then we'll do OK. Need a drink. Haven't talked this much in a while. Okay, so now we broke some things. And I think that's because now these two are actually overlapping a little bit. So we're going to undo what we just did and not go all the way down to 5. Maybe we'll make it go down to 5.5. That might work. Do 5.5, so there's still a little gap in between there. Yeah, a lot of funky things are happening. All right, let's hide this sketch. And then I'm gonna do a section view just so I can kind of see what's going on. And that doesn't help at all. Okay. Let's go back in history and just start from the beginning and just see where things are. So this initial sketch does not look correct. This should be on the outside of that spiral based on how this was made. Yeah, so that should be on the outside of the spiral. So if I go back into here, all right, that looks correct. So that's good. We'll hide the demo spiral. So that's correct, but it's just going in more than it's supposed to be. So I gotta go back to here, and this second distance, I just need to set to 0. Nope, first distance I need to set to 0. There we go, that's correct. And we gotta go forwards. Got that first LED. Right, now why am I not seeing any of my LEDs? Alright, something's definitely off with that pattern. So let's go back here. Let's turn on my first LED, make sure that's correct. Let's go to the pattern. And the profile is still dependent on where it was before, so I gotta just redo the same thing on all of them. No. That's confusing. Let's go back here. Now, how is that ending up on the outside of the spiral here, on the inside over here? Let's just redo this. And if you are just joining, make sure to check the chat where I left a link, which you should just be able to open up. That kind of explains the outline as to what we're trying to work on and do as of right now. All right, so something with that spiral is still wrong as of right now. Because it's starting, distance should be 0 here. 1 here, 0 here. Doing that again. So while this is a little bit of troubleshooting that I'm having to go and do, it's really not that bad because I'm not, none of the things I'm working, like the sketches or anything that I've been working with are broken as of right now. They're just not doing what I'm expecting it to do. So it's, I think, a little bit easier to troubleshoot what's going on. Let's see. When, you know, you don't have like a whole bunch of errors showing up that you're working with. So what I'm going to do is that I can actually wind this back down to see why this is not doing what it's supposed to be doing. So we'll start this 0.1. So it's wrapping around the interior, which is what it's supposed to be doing. Wrapping around the interior. I think it might just be because it's just wrapped around each of them so tightly, I just getting confused as to which one it's actually supposed to be going to or where it's supposed to be. We'll just say that's fine. Okay, so turn off the demo spiral. We'll say that's correct. As long as everything lines up again, that's all that really matters. Tape measure on there, that's correct. Let's see, LED, that's correct. Now what's going to throw it off is the pattern for those LEDs, right? No, that's actually correct. Okay. See, I don't think I actually changed anything. I just went and repeated the same steps for making the same components, or the same process, and it's correct now. I'm sure you can go back and watch and see what I did that actually may have done it, but sometimes reselecting the components that you're working with might be all that's required to getting it working. So I'm actually going to decrease the quantity here. Actually, no. So one thing I haven't checked again, which is probably pretty important, is the actual total length of this whole curve right now. So if I'm going to isolate everything except for the demo spiral, and I'm just going to measure this. So that's 800. What was the total length that I needed? So it is 872 right now, plus 75, so it's like 972. And I want it to be 48 inches, which is 4 feet. So I need 1,200, so I need to make it longer. So go back to this. Yeah, and I probably should have checked this before I went about trying to fix everything. So we'll change this to be 7, which probably is going to be too much, but we'll check and see. Now, maybe everything is going to magically still be working fine. Oh yeah, okay, so everything is actually still fine now. The LEDs are not in the correct order because there's the quantities of them that is required has changed, so that's going to be off right now, but that's fine. So let's just double check the length of this right now. So 1,462, so that's longer than I need. So we'll go back and we'll change the revolutions to 6 and see what that ends up with. Measure this. Okay. Okay, so this should be good. So this is at 1,150 plus another 75 millimeters is going up. So yeah, that's perfect. That's like exactly what we need. So just show all these components, make sure that's all good, and then I gotta make sure my LEDs are correct now. So now my total quantity has definitely changed. So let me just go back down to 0 and see where we start running into problems. And I'm going to do a section analysis just so I could see where the LEDs are actually going to right now. So I just went to Inspect, Section Analysis, and clicked on this, let's see, the XZ plane to be able to see it. So let's just keep on increasing this quantity, and you can see it going up the spiral. And it seems like 35 is the magic number well, 34 because we're taking one off there. Okay, so I think that's a pretty good baseline to be working with. So now we have this full tape measure figured out in terms of the dimensions of that, how tight of a spiral this needs to be. So let's see. I'm sure we could probably go a little bit tighter because I really want to make this as compact as possible. So let's see what size we're looking at right now. So I'm just going to make a rectangle right now. So that's roughly 90 by 90 millimeters of just having the coil inside there. So that's going to be, let's see. So 90 millimeters is that wide. So it's not going to be that small as of right now. So I'm going to try to make it a little bit tighter. I don't want to go too crazy because I still need to be able to have maybe not a diameter as large as I have in there, but still an internal diameter. So that way the wires that are actually connected to this have somewhere to go and those are able to spin without any problems. And yeah, so I need to have that, but I definitely should make the whole diameter still a little bit tighter. Unless, let's see. How does that clear casing that I added to the outside affect things? It's completely wrong. We're going to just delete that. And we'll get rid of that sketch I just made because that was just to get a rough order of magnitude. So all we care about right now is really getting how tight we can get it to compact as is. Yeah, it should be fine. I don't think that tightening it up like how this is as of right now is going to cause any short circuits or anything like that. So let's keep going at it. So we still have, let's see. What kind of distance do we have from the tape measure to the LED? Ooh, still 3.2 millimeters. So we still have quite a ways to go. So let's go crazy. Let's set this to 5. That may not even be enough. Let's set it to 4.5. And hopefully everything doesn't break. Demo spiral. Okay, everything actually looks good, except for the LEDs, which is expected to break every single time. So I'll just have, I literally just need to rerun it and then it fixes itself. So let's measure this again. So I'm going to do restart selection, so snapping point. And I can hover my cursor over into the middle here to select it. Or if I just have my mouse on the plane and then I hold down control, then it shows just the snapping points and it doesn't matter exactly where I have my mouse. It goes to the closest one. So I'll go to the middle one, go to that surface. Still 2.3 millimeters away, so I still have a lot of room to be working with. So let's try setting this down to 3. Alright, let's just see what these LEDs look like. Do this measurement again. Let's see, snapping point in the middle, that surface, 0.75. All right, we'll go down to, I guess, a little bit below 0.5 millimeters. Because, yeah, that should be fine. Because I don't know how tightly wound it's ever really going to be. Yeah, actually, I have to keep that in account, is that I'm never going to have it that it's like wound up as tightly as it could possibly be. Because there's just going to be up here a motor that's grabbing it and pulling it up and then pushing it back inside there. And if there isn't a spring in the middle holding, like pulling it all back together like what a tape measure does, then I don't think I'll be able to actually retract it back inside there unless the surface is pretty smooth, that there's not much friction as it tries pushing itself back in. All right, I think I'll leave it as where it is right now, and then we'll start making the housing that's going around it and test to see if we'll try making an actual prototype and see how that goes. So first, let me just fix these strenuous LEDs that are on here. So going back into the pattern analysis, turning off all these extra LEDs. I think that one. Okay, so that's fine. What's going on there? LEDs. That's not on there anymore. Why is that messed up? Check this again. Let's reset the path. Demo spiral. That edge. Turn off analysis. Yeah, it's off again. Right, you know what? I'm going to try. I'm going to try referencing this one off of the path of the actual tape measure and see if that makes it work as intended. Set this to 0. Is that what I want? Kind of. No, it broke. Alright, let's go back to this initial sketch that I made. And we're going to move it so that way the tape measure starts right on this dot, which is where that starting profile for the arc actually is. So we're going to have to break a few things. I need to break that coincident constraint that's locking everything there in place. So let's try that. All right, perfect. So that's one, that's another. We'll put those to the midpoint again. What the heck is that? Trying to see if I can get this back to where I was without breaking everything. Is that just a dimension? There we go. Seems like there's an extra arc here that I don't know what it was for. All right, that looks like everything that we need. But it is... Oh, this is not going too well. You know what, I'm gonna undo this. All right, let's just start from here again and just make sure this is correct. It just needs to make sure everything is referenced off of the same sketch, or the same line. So do demo spiral, turn off analysis. The path is that arc. And then we add this line at the end. Okay, that's correct. It's behind there, which is what it's supposed to be doing. Now this one is still incorrect. Let's turn off the steel tape and select. Yeah, it's still like going on the wrong side somehow. Because this is supposed to be, if I show the sketch that we're working with, let's turn off that. Yeah, so the first spiral is supposed to start all the way out over here. Let's just start fresh. So the path is going to be this profile. Sorry, the profile is going to be there. And then the path is here. So, but it keeps on making it smaller. It keeps on going internally, which is not what we want. So let's go 0 here, 1 there. All right, so that's correct. Well, kind of correct. This is the fun of CAD modeling on weird shapes. So that's fine, but that doesn't line up with the steel tape. It's like way off. Trying to think if it'd be better to make a separate sketch instead of referencing the triangle spiral to be able to be making this, taking that and then making a flat sketch that it's being referenced off of instead of this 3D object. I don't know if that's causing any more problems than it should be on this design. Actually, what I could do is, let's try this one more time. Let's delete that. Midpoint. Alright, so I basically want to move this whole thing Alright, so I don't want these two lines. These two can just be made horizontal. This is just the edge of the flex tape, which doesn't matter too much. So we'll just make those both horizontal. And we'll make that the midpoint there. Okay. right, so the whole sketch is still blue, which means something isn't fully constrained, so I need to figure out what still needs to be changed. So that could still move, so we want this to be horizontal/vertical. That's good. Now we still have something else. So if something's not fully constrained, I usually just like to click and drag to see where the problem could be occurring. And then that usually pretty quickly tells you what is not constrained. Set those horizontal/vertical. Now that shouldn't be able to move. Okay. Can't get everything to be all black lines again with how this is made, but everything looks pretty good. I mean, it's not all black lines, but I also can't get it to like click and drag to move it, so it does seem like everything is fully constrained. Alright, so let's check to see what that did to the CAD model. And that's exactly what we wanted. That's what it looks like. It's like, oh yeah, it's centered. Okay. Alright, that's good. That's exactly what we wanted. So the problem was, same thing as having with the LEDs over here, is that you want to have it so that way whatever profile that you're sweeping should be more or less centered around the path that it's going to be moving around. Otherwise it does some strange things. Alright, now we got all those LEDs in there. Let's turn the sketch off. And we'll do a section analysis to see. Yeah, that's probably tight enough. That's alright, and I'll just add some more LEDs back to this. $30. Okay. Seems like I still need more than that. Let's try 40. Is it just hiding them? Oh yeah, it's just hiding them. There we go. Oh, that doesn't look right. Why is it throwing a whole bunch of LEDs right there? 0, 2. Let's do starting point at 1. Alright, I think I need to move my LED again. Definitely once it's over, I'm gonna have to edit out all this boring stuff of figuring out how to fix a broken model. Alright, so let's hide everything else. So we'll hide that. Now why is it doing it? Let's try this starting from scratch. Select the component, select the line. Now, why is it trying to go in that direction? So that seems like the problem. Starting point is 1. All right, so set the quantity 2 and set this to 32.25. Here we go. Okay. I don't know why it flipped the direction in which it was actually placing the components. Let's try doing 20. 5. Oh, so going from 5 to 6 does some strange things. I think it's just having a hard time with how tightly wound this is now. I'm going to try adjusting the line just to start at the same height as it and see what that does. There we go. Now, it doesn't look like that's getting the desired result, but it's not broken anymore, so let's try. That's a lot of them. Let's try doing, we're at 30, and we're doing 32.25. Alright, they're on there, but they're at the wrong angle, so hopefully just adjusting this back will fix the problem and won't cause it to break again. There we go. I don't know why it broke before. Okay, that's good. Steel tape. Let's go show all components. Hide the demo spiral. Show all bodies. Okay. Let's double check to make sure everything with the steel tape is still correct. Okay. Whew, took a while, an hour and 20 minutes to get to where we are right now, but this is the foundation as to the LED strip, how it's going to be wound together, having that tape measure in there. Something I still need to decide is if I want to have it be spring-loaded, like a tape measure actually is. So inside of here, there's a tightly wound spring that when you pull on it, it puts tension on it and it wants to pull itself back in. And adding that would add a few benefits of it, like if we just have a motor on there, we need to decide, and let me just switch my camera. If we have a motor on here, we need to decide, or it needs to know what its starting position is. So if the system is turned off and it's like this, it doesn't know that it's out here in the middle or if it's over here. So we would need to have a mechanical switch that, you know, if you've ever used a 3D printer before, goes all the way back. It has a little button that it presses once it gets all the way back and it goes, okay, this is my starting position. I'm fully retracted. I know where to go from here. If we don't have a spring, then we need to have that kind of mechanical switch that will pull it all the way back in. But having a spring would make it so you didn't need that, because as soon as you took off the power for the motor, it would just automatically go all the way back in, because there's a spring pulling it in. But from what I've seen, that makes things a lot more complicated. So we're not going to mess around with that just yet. We're going to try seeing if we can make a version without it that actually still works. So there would just be a motor that is pushing this back in and winding itself back up. Not sure how well that's going to end up working, so we'll have to test and see. But the last thing that we're going to do for today is that we will make a rough housing that we can 3D print. And the next time I do a stream, which should be in another 2 or 3 days, I'll make an actual schedule and post it on the YouTube channel. Then I'll have a 3D printed prototype of that, and we can go about cutting, tearing apart one of these tape measures, and then seeing what's on inside, cutting one of the tape, the full 4 or 5 feet of tape that we're going to be working with, and then seeing if we could adhere that LED strip to it, so that way we can make this first initial assembly of really just proving out the concept that you can make an LED strip that could be wound up tightly, and that you can make it so that way it could be sitting underneath here, and it can hold its length and still be turned on and programmed and all that kind of thing. So that's all we're doing first, just proving that we can make an LED strip that can be wound up and pulled back out, and it stays straight using the functionality of a tape measure. So last thing, we're going to make a housing for this. So now that we're done with all this nonsense of figuring out how to make this spiral, I'll turn that LED off. We're going to make this housing. So the housing is going to be 2 parts. So I'll call this tape housing. And then we'll make 2 parts to that. So we'll have the back of the housing and the front of the housing. We'll see if I can design the first version so that way it's see-through. So that way we can just see it functioning, and so it's open on the front, and hopefully it doesn't just like explode outwards, which would suck. So we'll call this the back housing. So I'll create a new sketch. I'm not gonna reference off of this spiral or anything. Normally I used to, but because I'm almost positive the end diameter of this is gonna end up changing, it's gonna end up breaking the file, because this whole profile is gonna change and everything else was already breaking before. So I'd rather have something that is not linked to it to make it so that way at least my housing doesn't break every single time I go about making changes. So we'll start by just trying to make this pretty much as compact as possible. So this inner diameter, yeah, that should be good. 65, so we'll go 66. 66 millimeter inner diameter, and we'll make the wall thickness as 3 millimeters. I'll want to make it so that way we can mount a front plate on it. So we will make another rectangle. Yeah, we'll keep this as basic as we can go. So I'm gonna make this a tangent. Make a tangent all the way around, and then we'll add 4 mounting holes. That's gonna cross in the middle there. How do I want to make it sandwiched together? because I'm going to have to make sure I leave a slot out over here for the tape to be able to come out. So I'll make a line that's tangent there, which is good. Makes the width here. And that's going to be, sure, 6.5 millimeters. Yeah, it's fine if the one mounting hole isn't in the exact same spot as the other ones. This is just a prototype. And we'll do, I don't know, a 3 millimeter hole. Or we'll do 3.5 because I have M3 screws that I should be able to use. So I'll make these equal. One more over here. Equal. And I don't actually need this line. We'll just make it so it is 4 millimeters away from all sides. Oh, okay, cool, because I was already constrained on the line. It only needed one. Alright, and now for the last one over here. Okay, so that should be good. Now the last thing that we need in here is at the end of this, I think I cut it off. Yeah, so at the end of it there's gonna, oh shit. I didn't have, you know, I wasn't showing what I was actually doing. Okay, so all I did was I made a square going around it. I added 3 mounting holes in the corners and then added 1 mounting hole that's slightly offset. It is 1 hour, 32 minutes, and 30 seconds into here, so I'll know I have to go back and edit that out. Okay, so what I was saying is that in the middle of that coil, there's going to be a wire, something like this, that is actually going to provide power and control over the whole thing. So I need to make a hub where those wires can be fed into, and then still be able to spin and move around and that type of thing. So we'll make another 2 circles here. So this inner circle, we'll make it, let's see, 20? 20 millimeters in diameter. Seems like it should be a little bit more than that. If I do 25, yeah, that's good. And we'll do .5 millimeters in diameter there. Alright, yeah. Okay, so, and this should be more apparent in a second as to what this is all going to look like. I don't need 3 millimeters thick there. Okay, so let's extrude this all. And we're going to do this in both directions. You want it to be a little bit thicker than the actual tape measure. So the actual tape measure is 10 millimeters in width. So yeah, 12 is fine. 12 should be safe. So to do that, I'm going to make one more extrude that goes along just this back plane. So that way there's something for it to rest against. Or so it can't just pop out through this side. So I will set the start point from object and then push it out this way. So now there's a solid back. So that's good. Okay, and now we need to make the hub that's going here in the middle. So that's good. And this sketch, we actually want to make a separate cylinder there as well. And have it so those join together. Okay, and for this initial prototype, I'll make it so there's also a cover that you could put over the front. But this, for testing at least, should be fine. Shouldn't have any issues in printing this really at all. The last thing I need to do is I need to make it so there is, well, so the wire that's going to be connected over here has to be going through this, like through a hole in the middle, but this needs to be able to spin through the entire time. So that would really have to be a separate piece that mounts into there and spins along with the coil. So I can't have this inner diameter be part of the same body. So if I get rid of that, so I need a separate piece that has a hole on the side that's going to let the wires in, and it's going to spin with the tape measure as it winds and unwinds. So I'm just trying to think of what the best way to design that is going to be. So it's just a cylinder with a hole in the side, but it's more of just how do I want to mount that to this main body. Let's see, so I gotta make a new component. Oops, I didn't want to create a drawing. Let's see. Spinning wire holder. I mean, I can make it so the back plane goes on at a separate time. Or... Okay, you know, I think what the easiest thing to do is make it so that way... yeah, okay, I know what I'm going to do. So I am going to actually go back into this initial sketch I made, and we'll make the hole bigger that we're going to be working with. Make it so that's cut out. And now what I'll do is the spinning wire holder. Nope, what I thought didn't make any sense. Because it has to be able to spin pretty fast too. I really need like a bearing in the middle. Here, I guess let me just model the very basics as to what it is. So if you can't imagine what I'm thinking of, you can at least get an idea. So if we do something like this. So I'm going to do a revolve. So this is a half the profile of what I need to make. So we'll go midpoint. Sure. It's going to look something like that, and then I'm going to shell it. Okay, and then lastly, I need to add a hole going into the side of it for the wires to be able to go through. So I can make it a circle. Okay. So I think conceptually it should be a little bit easier to understand now. So just like on the end of these LEDs, there's going to be this wire that's attached to it, or some kind of wire that's on here, right here. And I need those wires to go through this hub, and then it's going to be connected to whatever's, you know, controlling the whole system. But this part needs to be able to rotate with the whole coil as it spins back and forth. So now that I have this basic you know, CAD as to what it's supposed to be done, I need to design a way that it's going to lock in there in place, so that way that's not going to ever come out. But also something that doesn't really add too much resistance to the whole system. Otherwise, the motor is going to have to be working harder than it needs to be able to pull the tape up and down. Yeah, now I'm thinking about it, there's no way I'm going to be able to get to be this compact, but or at least not with how it's currently designed. Okay, so what I could do is let's go to spinning wire. Let's go to the sketch for this profile. So all I'm going to make it do is I'm actually going to make some references from this. Sure, we'll project those lines. So we'll set a 0.25 millimeter offset there and have this line up the back. And we'll do the same thing over here. Not coincident. So once I put the lid that I'm going to design that's going to go on the other side on, that's actually what's going to lock everything in place. So I probably want this thing to be mirrored. Okay. So there's my profile. Yeah, that should be fine. All right, I broke the model. Let's do that. Okay, now all I have to do is make the front cover, and this is, I think, way thicker than it needs to be. So let's scale that down a little bit. And I'm gonna actually loosen up my tolerances more. 0.25 is probably tighter of a tolerance than is really necessary. I just need a loose fitting piece for now, just to really prove the concept. So we'll change this to 0.5. We'll change this to 1.5. There we go. Shell thickness 2 is fine. Okay, so last thing I need to do is create the front panel, which is going to lock the other end of this tube in place. And that means I could really have the wires coming out of either side. I'm not sure if it really matters which side it's coming out of as of right now. So let's go to tape housing, new component, front housing. Do I want to make a new sketch? I don't think I need to make a new sketch. I think I can go back to this original one that I had here. No, I'm not gonna make. I'm gonna make a new sketch. I could have referenced it off of that one as well, but I think it would have made it more complicated. So I'm just gonna project this original or this existing profile that we have here. And I think the main reason I'm doing that is simply because I want to project this profile that we have here as well. Or no, I actually don't want to project this. I want to just take this inner diameter that's here. Otherwise, I'd have to do an offset. Let's see. So I have that. I have that. Let's close this off. Don't need that. Okay, so I have all of that. Now, just so we could see internally inside of there, and so that way this doesn't just like pop out, we'll make a hub, so that way it's basically see-through in the middle here is what we want. We'll do 2 millimeters thick there. We'll have it so we can see this whole thing, and then we'll make four lines that are connecting this all together in the middle. So the easiest way is I'm going to do a center point rectangle and make 2 of them, and then I'll basically have this cross section that's going to hold it in place. So let's make those equal. Let's set this to be, I don't know, 7.5. And then I think we might actually want this more than 2. We'll go with 3. So now if I extrude this, we're going to want this new front panel to have all of this. And we had it 2 millimeters thick. Okay, that looks pretty good. The edges look a little bit weak, so I will fillet it so that way it's a little bit stronger over there. It looks like I missed a section over here. So I'll go back in the sketch, make sure that's selected. And I think I still want the middle to be thicker, so go back into here. We'll change this to be 5 millimeters. Yeah, that looks better. Alright, now I'm just selecting all these edges to fillet it so it's rounder, a little bit stronger, looks a little bit cleaner. Let's see what 5 looks like. Yeah, that's fine. Now, is there any chance of something like popping out and then running into problems because of that? I don't really think so. I think that should be good. Okay, yeah, I think the basic design is done. Let's turn the wire holder in together. Oh, last thing I'll do, I'm gonna add joints to this just so that way we get that taken care of as well. So for the tape housing, we're going to open that up, and the back housing we're gonna set to be grounded, which basically just means it can't move ever. And it's not referenced to anything, it's attached to the ground is what it sounds like. Now this front panel, I'm going to do Shift J, which is a built as joint, which means you're going to make a joint and it's going to stay exactly where it is. So I will make it connected there to the panel in the front, the component in the middle. I'm going to select it to be revolute around the front or back panel. And I'm going to change the motion type to be revolute. And I just pick the point in the middle, and that can rotate. Can't see that it's spinning. Let's try animating again. There we go. You can see that hole moving. That's good. And then we gotta we're gonna make the tape measure and the LED strip rigid as well, because those, well, it'd be cool if you get them animating. I don't think we could do that. So we'll set them both to be an as-built joint. LED strip is attached to the tape, and the tape, we'll say, is attached to this central hub in the middle. Okay, I think it's good. All right, well, thank you for watching, guys. I'm gonna start printing this, and then I will do a stream sometime later in the week once this is all printed, and then we will see how the test fitting of this goes. All right, thank you. Bye-bye.